All right, hello, ladies and gentlemen. This is Tim Sack, and I'm here to deliver you another uh, how-to tutorial on how to do cool things on your Ubuntu Linux system. Now, the current system I'm using here today for this tutorial is the latest LTS version of Ubuntu, which is 16.04. And I'm using the Xubuntu flavor, which is Ubuntu, which utilizes the XFCE desktop environment. I like the XFCE desktop environment more so because it's extremely light on resources. It has a very good graphical application layout, and it's easily customizable. There are several flavors of desktop environments, but the XFCE works well for me. Now, a while back, I created a video showing how to use an application called Gparted, which is used to create and manage partitions on your hard drive. There are, however, multiple ways you can create partitions on your hard drive. Um, you can use a list of graphical applications to do that, or you can create partition using the terminal, in which case you will be typing a series of commands to create partitions. But I find Gpod to be very easy to use. Gives a very good layout of the hard drive that's very easy to view and recognize and understand, and it's something that I believe should be installed by default on almost any Linux operating system. A good thing about Linux is that it offers choice. So you have the choice of to manage your system using either the terminal or a graphical application. So I'm going to go ahead and I'm going to pull up Gparted. And as you can see, this application is giving me a current view on how my hard drive is divided up. Now currently, if you look in the top right hand corner of the screen, you'll see a option menu that has an abbreviation of directories, DEV SDA. Now SDA stands for SATA drive, and the A means the first hard drive on your computer. Now, if you have multiple hard drives, it will say SDB, SDC, SDD, so on and so forth. But what that means is SATA drive. And on my system, I don't have any IDEs. I have all SATA interfaces. So it will represent that hard drive as being connected to a SATA interface. And A means that is the first hard drive. And of course, it gives me the actual size of the disk, which is close to 300 gigs. Now, this device is located under a folder from the root directory called DEV. Now, DEV is an abbreviation of device. Now, most or all hardware on your computer detected by your system will be stored under that directory. I'm sorry. Most of all your hard drives will be stored under that directory, but not all. However, your hard drives in particular will be located under the DEV directory for devices. So if you wanted to find your devices either through a terminal, you can actually just change your directory to DEV, and you can list all the devices that is detected on your system. So now, right now, what we're looking at is our first hard drive. Now, if you have multiple hard drives, you can actually select this option arrow from this menu. And if you have more than one hard drive, well, then you'll see a list of additional hard drives on your system detected by your system. And you can select either one of those for partitioning reasons. But in this case, we only have one hard drive, so we are defaulted to that. Now, if you look down below into the view screen, you have two views of your current hard drive layout. You have the bottom screen, which gives you the layout of your hard drive in categories, and then you have a view which gives the layout of your hard drives in blocks. I actually like the category view much better because it gives you more information on how my hard drive is divided up. And so currently I have two partitions. I have SDA1, which basically means partition 1, and SDA2, partition 2 of your first hard drive. Now partition 1 gives you the file system, which is the Linux swap partition, or swap memory is backup memory for your system RAM. In the case that your computer runs out of RAM, it can actually resort to saved hard memory on your hard drive, and that's where the swap space is coming from. It's a partition on your hard drive set aside for the system to use whenever it runs out of system RAM. Swap can also be used to allow your system to go into suspend mode in case you need to power down your computer if it was too idle, or if you had to walk away for a few minutes. You did not want your computer to use up electricity. You can use the Linux swap space to store a snapshot of your system and its current state and store it there. So when you come back to your computer and you power it back on, your computer will read that memory and swap and load back up your system in its current state that it was in before. So that's the benefit of swap. And as a matter of fact, most Linux operating system will not allow you to install a new OS unless you create swap space. You can actually get away with that, but in most cases, in default cases, you actually do need a swap partition in addition to your primary partition. Second partition down below, which is SDA2, which of course means second partition on the first hard drive. This is the partition where the operating system is stored on, and is mounted on the root directory with the file system of ext4, which means fourth extended journaling file system. The size of the file system is close to 140 gigs. Used is 43.99 gigs, and unused is close to 96 gigs. So this is the second partition. If you look on your far right hand side, you see flags. Um, the boot flag means that this partition is actually a boot partition, and the system, when it's booting up, will look for any partition with that flag to boot up the operating system. Now, strangely, swap actually has that boot flag, and swap does not have any operating system installed on. In fact, the swap more likely is a virtual file system for virtual memory. It does not really have anything installed on it. It's just extra space. So I am a little baffled of why that has boot flags, but nonetheless, my system boots up. So probably in the future I'll look into that and see what that is. But the second hard drive partition on my hard drive is the one that has my operating system installed on it. You can also tell which partition is mounted by that little key mark on your partition. That means mounted partition. You can select the partition and select right click it, and if you see a name that says unmount, that means that your partition is mounted, and you cannot resize or manage any mounted partitions. In fact, you have to unmount the partition first before you can do any work on it. And if your system is booted off that mounted partition and if you unmount it, you're going to get an error. So that is the current layout of my first hard drive, and so far I have two partitions created on there. So what I'm going to do now is I'm going to create a whole new partition of a different size, a particular file system, and I'm going to mount it somewhere. So the first thing we have to make sure we have is unallocated space, because we cannot create any new partitions if we don't have any free space to do it. So in here, since I have 150 gigs of free space, I'm going to create a partition using this unallocated area. Now you can either right click the unallocated space, which will give you a list of actions to do, or you can just go up to your menu bar and you can select the action from there. In this action, we are going to create a new partition. Now the current size of the partition is the size of the unallocated space, but we don't want to use all the unallocated space, because once again, this is just a little tutorial, a test to how to create a partition, so there's no need to use all the space. Now you can either type in the space that you want in megabyte form, or, and this is very cool, this bar at the very top with the arrows on both sides, you can actually use this to either decrease the size of your partition or increase the size. And then when you resize a partition, we're going to use a method similar to this to resize a partition. So I'm going to use this bar, and I'm just going to lower the total unallocated space to something around 20 gigs. And when you use any space when you're free space, the remaining free space will be shown in the free space following field. And once we use up close to 20 gigs, we'll have at least 134 gigs of free space left over. The partition type is going to be primary, or it could be extended. And if you turn the partition into extended, you can create logical partitions, which are, again, it's a logical partition is just a partition with another space. But the difference between an extended partition as contrast to a primary is that if you turn a partition into extended, you can actually create a bunch of logical partitions. But if every partition was primary, you only have the limit of 4 primary partitions. So if you want to create a bunch of partitions on your hard drive, it's best to start them off as an extended one. But this is going to be primary, so it's going to be okay because we only have 2 primaries. We can have a total of 4. This will be the third one. And again, this is just a test. So I'm going to label this partition so I can understand it or recognize it better, and I'm just going to call it something simple. So right now, our new size of our new partition is going to be close to 20 gigs. It's going to have a file system of a fourth journaling file system. You can select the file system drop-down menu, which will give you a list of supported file systems you can use on your partition. Um, Clearly, the ones that are grayed out are the ones that cannot be used, but the ones that are bold are the ones that can be. So we're going to stick with the default fourth extended journaling file system. We're going to click that. Once everything on our current screen is correct, we're just going to go ahead and click Add. And down here at the very bottom display screen from the overall table view of your hard drive layout, it's going to tell you what this program is about to do in your hard drive. Well, it's going to create a new partition with a particular file system, a particular size, and on what hard drive. So we're going to go all the way up to our menu action bar, and we're going to click the green check mark, which means apply all operations. Okay, your application is going to warn you that a change or is about to happen on your hard drive, which potentially can kill all your data. It's going to advise you that please back up your data if you have anything on there. This is going to warn you. And if you are safe and comfortable with what you're about to do, go ahead and just click apply. So the operation was complete. Now, if you want to get a more detailed understanding of what Gparted did to create the partition, well, you can select the details drop-down arrow. Now, this detailed drop-down arrow is like a log, and it's logging all the operations or steps that this program took to create a partition on your hard drive. First thing, so you can just go all the way down, so you can just read everything this program did step by step. Its first step it did was create an empty partition and gave it a new partition name. It gave it a size. All right, so that's the first thing it did. Second thing it did is start to clear out all file signatures on the system. It was writing 512 kilobytes of zeros. So it looked like it was zeroing out that space or that new section on your hard drive for a new partition. is set the partition type with a new file system of a fourth extended joining file system. But once I had all those criteria set, it went ahead and actually created the partition itself using a file called nkfs.ext4. Now, this little program right here, nkfs.ext4, that is a terminal-based command that you can type within your shell window or terminal to put a file system on a partition. And as a matter of fact, Gparted is a graphical application that, well, it's more of a graphical face to a terminal-based command. Uh, Applications that have a graphical interface um, are pretty much just a series of commands put together and given a picture, just like home or trash. All these graphical applications, all these pictures, they are just a series of commands that you can run in your terminal. The only difference is they are grouped together to perform in one step after another by clicking on an icon. And that's what Gparted really just did. It just took the commands that you have already available on your system and ran them step by step at a time. And all you had to do was just click a few buttons, and these things have been performed by the system itself. You can actually use the nkfs command to create different types of file systems on partitions. You also have a bunch of other commands in your terminal that you can use to create partitions. And what Gparted did is that it took the best commands, the easy uh, commands that are easily used, easily ran, and it used those commands to create the partition. So what Gparted did, it did not introduce anything new, but it gave a graphical phase to the terminal-based commands. So you don't have to type in commands, you just press some buttons. So once again, I'm going back to Linux offers choices. So now we've created our new partition on our, again, same hard drive, but this time we have three partitions. The third partition has a file extension of fourth extended file system. It hasn't been mounted anywhere, so we haven't really mounted into any directories yet. We label it test. The size is goes to 20 gigs, and we use no more than 482 megabytes for system information. So now we went ahead and we created our partition. Now, quickly, I'm just going to show you how to resize it. Again, these partitions that you're going to be working on cannot be mounted. They have to be unmounted for any kind of change to happen on them. So I'm going to go ahead, I'm going to right click it. Now you see this option that says resize and move. Well, we're going to use this option to resize the partition. Okay, so now we are going to resize our partition, and see this bar up top, as I showed you in a previous step, and how we use this to add new space. Well, we're going to use this to, again, add space or take away space. Now, you cannot, or I have noticed by performing this action, that you cannot resize a partition if free space is not following directly below it. For instance, partition number 2, which falls above partition number 3. Well, because partition number 3 is use space, I won't be able to resize partition 2 because no free space falls underneath it. I can resize partition 3 because space falls underneath it. But if there was no free space, there would be no resizing. So I'm going to resize this up to 28 gigs. And free space for remaining will be 126. And I'm going to go ahead and click resize and move. Again, the application is going to tell you what's about to take place. So you're going to go ahead and click that green check mark. Again, the warning prompt comes up, let you know that whatever is about to happen could be catastrophic. But if you're sure you know what you're doing, go ahead and select apply. Okay, so complete operation has been completed. And again, as I like to always do, check the details to see what actually happened on the behind the screens of this application. There was some kind of a calibration again that read the current path to that third partition, start size, new size. It checked the file system itself, and that was the command it used. And then it resized the partition. And growth, let's see, and it appears it used this command called resize to file system -p. So it looks like this was the command. First, it checked the file system using that command, and then it resized the file system using that command. Again, these commands are available within your terminal. So if you actually want to do this manually, you can use the same commands Gparted did. Again, Gparted did not introduce anything new, but a graphical face to your already available terminal-based commands. So we're going to go ahead and click close. Give Gparted time to reread the new partition in its new size. So now we have our same partition, which is partition 3, same file system. The only thing that changed was the size. So we grew our third file system, our third partition, from a size of 20 gigs to a size of 27. This has been written. The kernel, the system now recognizes that your first hard drive has now a total of 3 partitions. And now if we can go ahead, we can, let's see. I want to actually try to mount this so we can actually use it as an actual file partition. If you want to actually mount this partition to be used, if you right click the partition and you see that the mount option is grayed out, well then instead you can open up your terminal and you can type in your terminal sudo. Now again, when you are doing some kind of a system-wide change or any kind of changes that are going to affect the system, not your user account, you are going to need root privileges. And because I'm going to be mounting a partition, which means I'm going to be accessing a hard drive, and I'm going to put it somewhere within the root directory or any kind of directory, that will be considered making a system change. If it's not something specifically related to your account, you're going to need root privileges. So the command to mount a partition will be mount. And we're going to indicate the device we're going to mount. In this case, it's going to be our first hard drive, which is SDA partition 3. And we are going to mount it in a particular folder located on our root directory, which is MNT. And hit enter. It's going to ask us for our password. All said and done. Now, again, we can continue to use our graphical interface, our desktop environment, which is what it's there for. We're going to click our home folder. And our home folder is basically the file manager, which allows us to view available photos and files in our account. Well, one of those file systems is the MNT. Now, this MNT is located in the root directory. And if we double click on it, we're going to see that it is blank. There's something in there. But if we go to properties, you can, if you scroll all the way down to usage, you can see that the size of that folder is the same size of the third partition we created. So we took our new partition and we mounted it in a directory so we can use that to store files. Pretty neat, huh? And if we want to unmount it now, Gparted should detect that this is mounted. So what we're going to do is we're just going to try to refresh this. And look at this. Once we refresh our screen, Gparted had now showed us that we mounted a new partition on the MMT directory located under the root directory. And if we wanted to unmount this to make that MMT directory free, we just select the unmount button, and we just unmounted our new partition. So there it is, folks. This is a tutorial on how to use the graphical application Gparted to create new partitions on your hard drive. And we also demonstrated on how to resize the partition. Very importantly, um, having free space in your hard drive is very useful to have, very nifty. But no partition can be changed or configured if it's currently mounted, and you cannot resize a partition if there is no free space following under it. So unfortunately for partition number 2, we won't be able to resize that because I don't have any free space following directly under it. And if we try to resize this, what the system will probably try to do is take the third partition and try to reroute it or rewrite it to another area in the hard drive, making the whole hard drive geometry very complex to read and pretty messy. But this is just what I've noticed. I'm waiting to be anybody can correct me if I am wrong, but I've noticed that I cannot resize a partition if free space is not following directly under it, as in the case of SDA3, our third partition. So I hope you found this tutorial pretty helpful. Um, and stay tuned. If you do find it helpful, don't be shy to leave a comment down below this video and tell me what you think. And until next time, you guys take care of yourself.